Hello all, welcome to sksacademy. This is Sairaj. So today our topic is combination of resistance. So basically combination of resistance are two types basically, parallel and series combination. But in this session we will discuss about only series connection. So next session we will discuss about the parallel connection. So first of all, what is resistance? Okay na? What is resistance? So resistance is nothing but, suppose this is the actual symbol of the resistance. Symbol of the resistance is this one, is the symbol of the resistance. So resistance is, it is the opposing the flow of current. So according to Ohm's law, how do you know what is Ohm's law? Ohm's law is V is equal to IR. Ohm's law is V is equal to IR. So R is equal to V by I. R is equal to V by I. According to Ohm's law, resistance R is equal to VI. So simply R is the inversely proportional to the current. R is the inversely proportional to the current. R is the inversely proportional. So if suppose example, if current is increasing, resistance is automatically decreasing. So if suppose current is decreasing, resistance is increasing. Simply resistance is opposing the flow of electrons. Simply it is opposing the flow of current. Okay na? Sir, okay. Suppose if resistance is taken, I give electrical energy to the resistor, but resistance gives heat energy. Simply the energy, electrical energy converted into the heat energy. Okay na? Because energy neither created nor destroyed, but it can converted into one form to another form. So that's why electrical energy converted into the heat energy. Okay na? Because simply resistance definition, resistance is the opposing the flow of electrons and produce heat energy. This is the definition of resistance. Okay na? Clear. So according to Ohm's law, R is equal to VI. But actually if simply take one conductor, okay na? So simply take, this is suppose example, take one conductor. This is the one conductor. So this is length of the conductor. Okay na? So this one is the A is the area of cross section. Okay na? So rho is resistivity. This is also known as specific resistance. Okay na? So what is a specific resistance? Is this completely depends upon the material. Okay na? So నువ్వు ఏదైతే మెటీరియల్ తీసుకుంటావో డిపెండ్స్ అపాన్ ద మెటీరియల్ బట్టి స్పెసిఫిక్ రెసిస్టెన్స్ వాల్యూ అనేది చేంజ్ అయిపోతుంది. సపోజ్ ఎగ్జాంపుల్ ఐరన్ ఈజ్ డిఫరెంట్, copper is different. Okay na? So according to the material, specific resistance value will be changing. Okay na? So resistance R is equal to rho into L by A. So simply resistance is directly proportional to the length of the conductor, and resistance is inversely proportional to the area of the cross section. So simply combine those two. R is directly proportional to L by A. We eliminate the proportionality constant, we are putting some constant value. That constant value is called as resistivity. So R is equal to rho into L by A. This is the formula of resistance. R is equal to rho into L by A. This is the basic definition of the resistance. Okay na? Symbol of the resistance is this one. So what are the units of the resistance? Okay na? So units of the resistance is ohms. Units of the resistance ohms, denoted by like this. This is the symbol ohm. Okay na? So this is the basic definition of the resistance. Symbol, formula, R is equal to rho into L by A. According to Ohm's law, R is equal to V by I. Okay na? So now let's continue the first of all series combination. Okay na? So series combination means, simply suppose take, okay na? So we have two conductors. Yes or no? This one is 1, this one is 2. So if one end of the conductor is connected to the another end of the conductor, if one end of the conductor is connected to the another end of the conductor, this combination is called as series combination. Simply clear? So let us take series combination. This is one resistance and this one is the another resistance. Okay na? So we take current I is passing through the this two resistance. This is R1, this is R2. Okay na? So this is R1 and R2. Clear? So next, if voltage V is applied across this two resistance. Okay na? So let us consider this is one is V1 and this one is V2. Okay na? This one is V1 and this one is V2. Okay na? Clear? So V1 and V2. So next, if according to Ohm's law V is equal to IR, according to Ohm's law V is equal to IR. Suppose if two resistance R1 and R2, if suppose example three resistance are connected like this, 1, 2, 3, we connected n number of resistances, one end. Suppose R1 end is connected to the R2 and R2 end is connected to the R3. This is the series combination. Okay na? Understand? See what is series combination? So if series combination, one end of the resistance is connected to the another end of the one more resistance, that is called as series connection. Okay na? So if this is the basically if combination of resistance in series combination. Okay na? So now this is the circuit representation, series representation. Okay na? So we are applying one battery applied. We have this is B1, B2 and B3. Okay na? So this is which combination? Like electrons flowing like this. Okay na? B1, B2, B3. This is the series combination. One example. This is also one other example, series circuit current. Okay na? We are applying some 2 amperes to whatever. This is voltage applying. So some examples we are seeing, example 1 and example 2. So what are the series circuit? Okay na? So now series combination. So now derive the total combination of the equivalent resistance. Okay na? So let's see. This is R1, R2, R3. Three resistance are combining in series combination. So V1, V2, V3. V1, V2, V3. Okay? So V1, V2, V3. So let's see. So total according to Ohm's law V is equal to IR. So total V is equal to, let's divide with suppose example here R1, R2, R3, V1, V2 and V3. Okay na? So total V is equal to V1 plus V2 plus V3. Total V is equal to V1 plus V2 plus V3. So according to Ohm's law, V1 is equal to I into R1 plus I into R2 plus I into R3. Remember one thing, in series connection current same, no change, but voltage should be changed. Okay na? In series connection current same, voltage change. So that's why in all resistance, in whatever in series lo 100 number of resistance unna gaani all resistance current should be constant. Okay na? I only. So that's why V is equal to V1, IR1, IR2, IR3. So total V is equal, suppose we can I into R equivalent. So I into R equivalent. So take I as a constant, R1 plus R2 plus R3. R1 plus R2 plus R3. So total I get cancelled. R equivalent is equal to R1 plus R2 plus R3. If suppose example we are adding more number of resistance, if whatever up to Rn, this is the formula. If R equivalent is equal to R1 plus R2 plus R3 so on up to Rn. If n number of resistance are connected, the total R equivalent of the resistance in series combination is equal to sum of the individual resistance. That is the series combination total R equivalent. Okay na? Clear? So now this is the same, V is same, just R equivalent is equal to R1 plus, and we take 3 resistance R1 plus R2 plus R3. Okay na? So now look at series. In suppose example in series combination we take 2 resistance. Remember one thing ma, in 2 resistance combination take two conductors are different. Let two conductors are different. So this is length L1, this is length L2. In series combination we are not considering area of cross section. Suppose we are considering only length is different, area of cross section is same, and rho is what? Specific resistance is same. Okay na? So according to your formula, R equivalent is equal to two resistance are connected, R equivalent is equal to R1 plus R2. This is clear. So now according to your formula, R is equal to what? Rho into L by A. R is equal to rho into L by A. So R equivalent is equal to rho into L equivalent by A. L equivalent by A. So next R1 same. R1 sorry, here this one is rho. Okay na? Rho into L equivalent by A, and same R1 is equal to rho into L1 by A plus rho into L2 by A. Clear na? So because rho by A is a constant na, take outside rho by A, L equivalent is equal to, so take rho by A is a common here also, by L1 plus L2. Clear na? This one cancel. So finally L equivalent is equal to L1 plus L2. If two resistors are connected in series combination, total length, equivalent length is equal to L1 plus L2. This is important. If what? Area of cross section is constant. Rho is always constant because it is depends upon the material. Okay na? So this is about the one of the important concept. If total equivalent length of the conductor, L equivalent, if in a two resistors or two conductors are connected in series combination, L equivalent is equal to L1 plus L2. Clear? Okay. So now in series combination, so okay na? So in series combination, if voltage is applied across, suppose example ma, see this is already R1, R2, R3, three resistors are connected. Suppose these three are connected in one battery. Okay na? This one is battery, positive, negative, apply voltage V. So remember first point, the current in each resistance is same. The current in each resistance is same. Which connection? In series connection, you take 100 number of resistance, but current will not change. Current will be always same in each resistance. Okay na? You take R1, R2, R3. I am applying current I here. So here also I, no change. In series connection, current will be always constant. Okay na? Clear? So I is equal to I1 is equal to up to so on IN. In current in each, the current in each resistance is always same in which connection? Series connection. Okay na? Clear? Next, the potential difference across each resistance is proportional to its resistance. But what changing? In voltage, in series connection, voltage will be changing. In series connection, voltage will be changing. See, if V will be applied across the total resistance, changing na? V1, V2, V3. Because of resistance changing, automatically voltage is also changing, because there is also directly proportional. Directly proportional means if resistance is increasing, automatically voltage is also increases. If resistance is decreasing, voltage is decreasing. This is the directly proportional means that if resistance is increasing, automatically according to the resistance values, voltage will be directly proportional. That okay na? Clear? This is the important topic. If in series connection, voltage will be changing, current is always constant. Okay na? So in domestic purpose, that's why only we are choose only domestic purpose parallel connection only, not series connection. Okay na? Suppose we take series connection, voltage will be fluctuate. That's why we choose parallel connection in domestic electrical connections. Okay na? Clear? So this is one important note point of 1 and 2 point. If current is always constant in series connection and voltage changing in series connection. Okay na? So now series combination. So already last మనం డిస్కస్ చేసింది ఏంటిది? In series connection voltage will be dividing. సో హౌ టు ఎలా డివైడ్ అవుతుంది అనేది మనం డిస్కస్ చేద్దాం. ఓకేనా? సపోజ్ ఎగ్జాంపుల్ ఇన్ దిస్ ఇఫ్ టూ రెసిస్టెన్స్ ఆర్ దేర్ R1 and R2. ఓకేనా? సో R1 and R2 we are applying total voltage V. Clear? So here V1, here V2. So I need V1, V2 individually. V1, V2 individually. So simply దీన్ని మనం ఏమనొచ్చు అంటే వోల్టేజ్ డివైడెడ్ రూల్ అని అనొచ్చు. ఓకేనా? సో వోల్టేజ్ డివిజన్ రూల్ అని కూడా అనొచ్చు. ఏమనొచ్చు? వోల్టేజ్ డివిజన్ రూల్. ఓకేనా? సో ఇఫ్ టూ రెసిస్టెన్స్ ఆర్ ఇన్ సిరీస్ కనెక్షన్ we are applying total voltage to some two resistance, but individually R1 is separate voltage is there and R2 is separate voltage is. How to find out that R1 voltage at R1 and voltage at R2? Okay na? Clear? See, first of all we find out voltage at R1. Voltage at R1. So voltage at R1, voltage at R1. So okay na? So voltage at R1, VR1 is equal to total voltage. Total voltage means battery voltage. Total voltage into whatever resistance is R1. So R1 by total resistance. R1 by total resistance. Voltage at R1 is equal to total voltage into same resistance by total resistance. Simply voltage at R2. Voltage at R2. Total voltage into R2 by same total resistance. This is the voltage division rule. Okay na? So voltage at R1 is equal to total voltage into simply నీకు ఏ రెసిస్టెన్స్ దగ్గర అయితే వోల్టేజ్ కావాలనో total voltage into that resistance by total resistance. This is the voltage division rule. Suppose okay na? సో సింప్లీ మనం జనరల్ ఫామ్ రాసుకోవచ్చు అంటే ఏం రాసుకోవచ్చు? వోల్టేజ్ ఎట్ వాట్ రెసిస్టెన్స్, నీకు ఏమి రెసిస్టెన్స్ దగ్గర కావాలనో వోల్టేజ్ ఎట్ రెసిస్టెన్స్ ఈజ్ ఈక్వల్ టు టోటల్ వోల్టేజ్ ఇంటూ సేమ్ రెసిస్టెన్స్ బై టోటల్ రెసిస్టెన్స్. సేమ్ రెసిస్టెన్స్ బై total resistance. This is the voltage division rule. Clear na? So okay na? So because in series connection voltage is divided in but current is same. So that's why R1 is separate voltage is there and R2 is separate voltage is there. So this is voltage division rule. Okay na? Clear? So now see one example problem చూద్దాం ఒకసారి. So question ఏమి ఇచ్చింది చూడండి ఒకసారి. The potential difference of 6 voltage is applies across AB. ఓకేనా? A and B టూ టర్మినల్స్ మధ్యలో 3 రెసిస్టెన్స్ ఇచ్చిండు. ఆ టూ టర్మినల్స్కి ఎంత 6 వోల్టేజ్ బ్యాటరీ అప్లై చేసిండు. డిటర్మైన్ ద పొటెన్షియల్స్ డ్రాప్స్ అక్రాస్ ఈచ్ రెసిస్టర్ దగ్గర ఫైండ్ అవుట్ చేయమంటాడు. ఓకేనా? అంటే ఇప్పుడు ఏంది మనకి ఇన్ సిరీస్ కనెక్షన్ వోల్టేజ్ విల్ బి డివైడెడ్. ఓకేనా? వోల్టేజ్ డివైడ్ అవుతుంది. అది ఎలా డివైడ్ అవుతుంది? ఒక్కొక్క రెసిస్టెన్స్ దగ్గర ఎంత వోల్టేజ్ డ్రాపింగ్ అనేది జరుగుతుందో ఫైండ్ అవుట్ చేయమంటాడు సింప్లీ. ఓకేనా? సి సో టోటల్ ఇన్ బిట్వీన్ దోస్ టూ ఏబీ టర్మినల్స్కి మధ్యలో మనం ఎంత అప్లై చేసిండు? 6 వోల్టేజ్ అప్లై చేసిండు బ్యాటరీ. ఓకేనా? 6 వోల్టేజ్ అప్లై చేసిండు. బట్ సింప్లీ మనకి ఇక్కడ ఇంకా అడ్వాంటేజ్ ఏంటంటే ఇఫ్ త్రీ రెసిస్టెన్స్ ఆర్ ఇన్ బట్ ఐడెంటికల్ సేమ్ రెసిస్టెన్స్ కదా, 2 ohms 2 ohms 2 ohms. సో ఒక దగ్గర ఫైండ్ అవుట్ చేస్తే ఆల్ ఆర్ సేమ్. ఓకేనా? సింప్లీ ఫస్ట్ వోల్టేజ్ ఎట్ నేను 2 ohms దగ్గర ఫైండ్ అవుట్ చేస్తున్నా. ఫస్ట్ 2 ohms దగ్గర వోల్టేజ్ ఎట్ 2 ohms. బస్ ఇన్ సిరీస్ కనెక్షన్ కదా, సిరీస్ కనెక్షన్ టోటల్ వోల్టేజ్ ఎంత మనకి 6. బట్ టోటల్ వోల్టేజ్ 6, టోటల్ రెసిస్టెన్స్ ఈజ్ ఆల్సో 6. టోటల్ వోల్టేజ్ ఇంటూ సేమ్ రెసిస్టెన్స్ బై టోటల్ రెసిస్టెన్స్. 6 క్యాన్సల్, వోల్టేజ్ ఎట్ 2 ohm రెసిస్టెన్స్ 2 వోల్టేజ్. సో అంటే ఇక్కడ 2 వోల్టేజ్ ఉందంటే ఇక్కడ 2 వోల్టేజ్ ఇక్కడ, ఎందుకంటే 3 ఆర్ ఐడెంటికల్ కాబట్టి వోల్టేజ్ కూడా ఐడెంటికల్గా డివైడ్ అవుతుంది. సో విచ్ ఆప్షన్ ఇస్ కరెక్ట్? సో ఆప్షన్ డి ఈజ్ ద కరెక్ట్. సో ఓకేనా? సో వన్ మోర్ నోట్ పాయింట్ ఏంటంటే ఇక్కడ రిమెంబర్ వన్ మా. ఓకేనా? సో మనం ఇక్కడే చెప్పేస్తే ఒకసారి నోట్ పాయింట్ కూడా చూడండి. ఇఫ్ ఐడెంటికల్ నెంబర్ ఆఫ్ రెసిస్టెన్స్ ఆర్ కనెక్టెడ్ ఇన్ సిరీస్ కాంబినేషన్లో ఐడెంటికల్గా కనెక్ట్ అయినప్పుడు ఇక్కడ ఒకటి చూడండి అమ్మ. ఇఫ్ ఇక్కడ ఏమన్నా R1 R2 R3 అనేది 3 డిఫరెంట్గా ఉన్నప్పుడు మనకి కాంబినేషన్ ఏంది R equivalent is equal to R1 plus R2 plus R3 if n number of identical resistors are connected in series. If n number of identical resistors are connected in series, total R equivalent is equal to simply ఏం రాసుకోవచ్చు n into R. N into R. So what is n? Suppose example, I connected each resistance is 2 ohms. That 2 ohm resistance 100 resistance are connected in series. So n is equal to 100, R is equal to 2 ohms. Total R equivalent is equal to 2 into 100, 200 ohms. Simply. Okay na? If n number of identical resistance are connected in series connection, R equivalent is equal to n into R. This is the important. మనకి n number of connection చేసుకున్నప్పుడు సింప్లీగా క్యాలిక్యులేట్ చేసుకోవచ్చు. ఓకేనా? సో ఇప్పుడు మనకి ఎగ్జాంపుల్ 1 ఆప్షన్ ఇస్ 2 volts 2 volts 2 volts బికాస్ 3 రెసిస్టెన్స్ ఆర్ ఇన్ ఐడెంటికల్. దట్స్ వై ఒక దగ్గర ఫైండ్ అవుట్ చేస్తే మనకి ఆల్ దగ్గర సేమ్ ఉంటుంది అన్నట్టు. సో నెక్స్ట్ వన్ మోర్ ఎగ్జాంపుల్. పొటెన్షియల్ డిఫరెన్స్ ఆఫ్ సేమ్ 6 volts ఈజ్ అప్లైడ్ అక్రాస్ AB. డిటర్మైన్ ద పొటెన్షియల్ డ్రాప్. బట్ ఇయర్ చూడండి, ఇంతకుముందు మనం ఏం చేసినాం అన్ని 2 ohms 2 ohms 2 ohms తీసుకున్నాం. బట్ ఇప్పుడు ఇక్కడ ఏం చేస్తున్నాం 1 ohm 2 ohm 3 ohm 3 డిఫరెంట్గా తీసుకున్నాం. చెక్ ఇట్. సేమ్ ఫస్ట్ వోల్టేజ్ ఎట్ 1 ohm రెసిస్టెన్స్, వోల్టేజ్ ఎట్ 1 ohm రెసిస్టెన్స్. సో టోటల్ వోల్టేజ్ హౌ మచ్ 6 volts నా. ఓకే, సో 6 into 1/6, 6 into 1/6 how much 1 voltage. Simply remember ma, if resistance is increasing automatically voltage is increasing. Same voltage at 2 ohms, 6 into 2/6 how much 2 voltage. So voltage at 3 ohms, 6 into 3/6 3 voltage. Simply how much total resistance is 6 ohms resistance, 6 voltage is applied. So 1 ohm resistance దగ్గర 1 voltage, 2 ohm resistance దగ్గర 2 voltage, 3 voltage దగ్గర 3 ohm resistance దగ్గర 3 voltage. So option C is the correct. Okay na? So this is about the series combination of resistance and with examples. Clear? So if n number of resistance or identical resistance are connected in series combination, total equivalent resistance is equal to R into N. If n number of different types of the resistance are connected in series combination, R equivalent is equal to sum of the individual resistance. Simply one more point, if in series combination voltage is divided but current is constant. Okay, this is about the series combination of the resistance, and next session lo manam parallel combination of the resistance discuss cheddam. Okay na? Thank you.